Hello, everyone. Thank you for joining us here on this webinar series put on by the Armando Alvarez Group, the Agri-Plastics Community, and ARC Agriculture. We appreciate you tuning in at this time. This is part one of a three-part series about silage. This first webinar is about silage clamp design. We brought on an expert, Will Wilson. First, I'd like to describe a bit the sponsors of this webinar series. The Armando Alvarez Group and the Agri-Plastics Community, which is a website platform owned by the Alvarez Group. The Armando Alvarez Group is a 100% privately owned family company headquartered in Cantabria, which is in the north of Spain. The group started as a small company, has grown to encompass 17 different individual companies that are active in over 100 countries around the world. Through these 17 companies, the group meets the need of a very diverse sector of products and customers. They are all complementary and include packaging, agriculture, geosynthetics, and forestry. The Alvarez Group has chosen a circular economy model that will guarantee sustainable growth over time, promoting resource optimization, reducing the use of raw material, and reusing waste products by recycling and giving them new life. You can find out more at gocircularplastics.com. ARC Agriculture is based in the UK, and they provide expert advice in all aspects of silage storage, from silage clamps to silage sheets. ARC is the foremost expert in sloping wall and vertical wall silage clamps for dairy and livestock farmers and anaerobic digestant plants. ARC Agriculture provide unique, industry-leading products to help their customers produce high-quality silage. All their silage, plastics, and netting are fully recyclable. Today we have here Will Wilson. He's the Business Development Director at ARC Agriculture. As I said earlier, they provide silage clamps and covers across the UK and internationally for biogas and livestock farmers, with over 150 sites using their clamps in the UK. Will has helped develop the business from its conception in 2013. His background in practical farm and business management, which helps him understand ways silage storage can be improved at a farm level. Without further ado, I welcome Will to join us here and begin the webinar. Thank you, Will.
Brilliant. Thank you very much, Trevor, and thank you to the Agri-Plastics community for inviting us on today to talk about silage clamp design. We did a great practice session earlier about this, and I explained that I can talk a lot about silage clamps and silage storage. So I'll try and keep it as short and sweet as possible, and basically talk you through the different points to consider when you're looking at silage storage. Trevor did a really good job of explaining who ARC Agriculture are. So those are my contact details. I'll put them up at the end as well. Please put any questions you have as we go through the presentation through the Q&A button at the top of the Zoom panel here. Or if you'd like to talk to us direct, drop me an email on the following contact details. I noticed that a lot of the attendees are from all over the world. So I will sort of say straight off that a lot of what I'll be talking about is UK-based silage storage. There may be differences in other parts of the world, but I hope that generally what we talk about is relevant for most people. And I'll do my best to sort of give broader advice that I hope is relevant. So a bit about ARC Agriculture. We supply patented the sloping wall design silage clamp in the UK. We also work with partners in Holland to supply vertical walled silage clamps. And we do the oxygen barrier silage films, nets, and clamp accessories. So we try and provide a complete package to improve your silage storage. In the UK, we have 120 clamps, predominantly split between biogas or anaerobic digestion plants and dairy and livestock farms. If you look at the map here, if you were to split the country from top to bottom, on the right-hand side, those sites are mostly for AD and livestock, AD plants, so biogas renewable energy plants. And on the left-hand side, they're mainly for dairy and livestock, so feeding animals, basically. I think to date we store over 2 million tons of silage in our clamps, so we've got a pretty large sort of feedstock variability going on there. And as I mentioned, we try and provide the complete package. So when we talk to you about silage clamp design, we're talking about the total storage, not just the walls. We're talking about the whole package. So moving on. So when we talk about silage storage, it's essential that we remember why silage storage is so important. And when we start talking about silage storage, what we actually mean is losses. So we refer to silage quality in terms of losses. We assume that silage is perfect when it goes into the clamp, and then basically what we're trying to do is avoid losing any of that energy, the sun's energy in effect, that's been stored in the silage during the clamp process and in the ensiling and the storage of it. To give you an idea of where these losses actually come from, for example, grass, well, it's worth pointing out that some losses come from the actual process of harvesting. So, you know, the collection of material from the fields. This could be physical, so literally stuff that doesn't enter the trailer or blows out of a trailer that leaves a field to return to a silage clamp. But the majority of the losses actually come from within the clamp, which is referred to as respiration and fermentation losses. These are the losses that you might not see so often. And possibly one of the only ways you'd know they're happening is to basically see the clamp warm up. This is why it's so important to design your silage clamp right, because those respiration and fermentation losses can equal 10% fairly easily and can be significantly higher in badly designed silage storage. If we then add on top the losses that you might occur in from the surface, so the bit you probably would see black silage, moldy silage on top of your silage clamp, then you could easily see easily see sort of high 10 to 20% losses, which is an enormous amount of material to be losing during your silage storage process. And just to really hammer that home, let's just talk about the respiration and fermentation losses of 10%. If you're an AD plant or a dairy farmer, you've got to think, if I'm spending £1 million on silage, which is quite possible with some of the bigger AD plants, I'm losing 10% of that every year in my storage because possibly because of the silage clamp design and the way I'm covering the silage clamps. That's a huge amount, especially if you then say, well, my AD plant or my biogas plant's got a 20-year lifespan. You may also say, well, I've also got to replace that lost silage with feed that I have to buy in. So it's a bit of a double whammy. It's what you lose in the clamps plus what you have to buy to replace what you lose in the clamps. And you add those costs together and you realize how important storing silage is. It's absolutely essential to the financial success of your AD plant or dairy or livestock farm. A really, really practical way to think about it is, would you accept a 10% loss in a grain store, for example? So if you're storing a lot of grain or barley or cereal products, would you be happy pouring 10% of the grain that you harvest that year down the drain? Because that is in effect what you're doing if you're not doing your best or at least achieving really significant reductions in silage clamp waste. So keep that number in mind throughout the presentation, and hopefully it will explain a bit more about why we think it's so important that silage clamps are built correctly and how we can help you come up with better designs to improve that storage and reduce those losses. So the first sort of thing I think that everyone wants to think about, and particularly reminder, this is the UK, very UK centric, so it may be different in different parts of the world. The first thing to think about is what type of system are you going to use to store your silage? So in the UK, we have 4 fairly common different ways of storing silage. I haven't included baled silage in here because baled silage is perhaps a different topic and not one that I'm particularly aware of, but I tend to talk about silage clamps. So the first system is, if you look top left, it's basically the arc. It's a sloping walled system, so a concrete panel against an earth bank. We've been working very hard in the UK to develop this system and try and get people on board with something like this, you know, to understand the benefits of sloping walls. So they have better compaction against the walls, slightly safer to use. The disadvantages to sloping walls are they tend to take up more space. So that's option A. going around to the top right then is option B, and this is something I'm sure lots of people recognise. It's an ag bag. It might be called a sausage. We've plastic sausages. I've heard all sorts of different descriptions. Fairly common, I know, in drier parts of the world. So might be used for grain maize, for example. In the UK, they are used for storing grass or maize silage. Lots of advantages to this sort of system. Very flexible, so you can increase your storage by basically allowing for a larger bag. You can double the bag volumes. You can also site your storage where you want it relative to where you're going to end up using the product. So you can, move your silage to where you need the silage to end up. The slight disadvantage to the ag bag system, especially in the UK, is it tends to be very hard to work with in the winter. So unless you've got a large open concrete area, you'll spend a lot of time basically working in very muddy conditions over winter, trying to empty them. If you put them on the edge of fields, that isn't great, and obviously it causes the issue of contamination of silage and bits and pieces like that. So they definitely have a role, but they're perhaps not the first choice unless you need that emergency sort of temporary storage. Coming down to the bottom left, this is the picture with the sort of lots of vertical wall clamps with the steel posts that stick up in the air. This is a typical example of a very sort of old-fashioned, I want to say old-fashioned design of silage clamp, but we still see in the UK, we still see them being built like this. There's nothing wrong with these designs. The challenge of this older style clamp with the concrete panels and the vertical steel beams is that they are not always designed for the weight of modern machinery. So the biggest problem we have with modern machinery is that everything gets heavier. Contractors particularly, so if someone else is fitting the clamp on your behalf, their machinery will be getting heavier and heavier. And a typical design like the one in the bottom left there will possibly have been built with, I guess, the farmer's own sort of DIY skills. So it might not have any sort of tolerance or design specific for a weight of tractor. So the challenge of those clamps is that they aren't always as stable as they ought to be. They do tend to fall over. They do tend to leak. I guess the advantages to those clamps is that they are cheap and relatively simple to build because it's a standard design. You just put some concrete panels between some steel posts and basically hope it doesn't fall over. The bottom right is kind of, this is a worst case scenario. Unfortunately, we do still see silage stored like this in the UK. It's basically a flat pad. We would refer to it as field silage. So it's silage that's stored on a flat area, perhaps in the corner of a field, perhaps on a concrete pad if it's sort of if they have that facility. The biggest challenge here is obviously, I think, first point is probably a pollution problem. So if there's no way of handling the leachate that's going to come off the silage, it's going to go into a watercourse and it will cause a pollution problem. And there are instances in the UK where that's become quite an expensive, there have been some significant fines for people doing that. So you've got to be super careful if you're going down the route of the field silage in the bottom right-hand corner. Ultimately, the other massive challenge is contamination of silage with the material, so the base, whatever you're storing the silage on. And also, it's just really hard to get silage quality right in that sort of design. The terminology I think we'd use is hygiene, so silage clamp hygiene. It's really poor hygiene. In that example in particular, you can see, there's already areas of contamination. There are random bits of wood and mud and all sorts of bits. And you sort of look at that and you go, that is the sort of silage clamp where you'd expect 20% waste. And actually a total false economy. It could be very expensive and very dangerous for the environment to store silage like that. So really not one we would advise, but we do understand sometimes that's where people have to go in emergencies, I guess. So coming right back to the very beginning, imagine we were going to start again with a new design of silage clamp. I thought I'd talk through the points that we would consider if that's what we were trying to do. So if we were asked to design a silage clamp, which we often are, we take a slightly different approach perhaps than a lot of other companies, in that we start with the principle of making the best possible silage quality at the beginning, and then we bring together all the different elements that we understand to achieve that. So we start based on our knowledge of silage quality, we work backwards, and that's how we design the storage. And I think that's the best way to approach this, is to say, I want to achieve the best possible silage quality. To do that, I have to do this, this, and this, and therefore my silage clamps will have to be this long, this wide, and this high. And it's fairly simple to get that right. So what we would use is quite a complicated calculator, which will take into account the different opportunities I'm going to go through in a second. The first point I'll make is, again, this is very UK centric perhaps. A lot of people tend to put vertical walls with a back wall in on a silage clamp. The first thing we'd always say to someone is actually don't worry about the back wall. So just keep 2 parallel walls. It doesn't affect silage quality. If anything, it improves it slightly. It might actually make your silage clamp slightly cheaper to build. And it certainly it adds a bit of flexibility to the design. So the first top tip when you design your silage clamp is don't worry about a back wall, remove that completely. The next sort of points that we'd look at, so we've decided we're not going to have a back wall. Now we have to decide how wide and how long we want our silage clamp to be. And this would include a big flat pad. So the same principle, if you didn't have walls and you just had a big flat area, you'd still want to design the width and the length of the pile you're building. The first thing we consider is feed out rates. Being very broad, a feed out rate is the speed a silage clamp is emptied. So if what we aim for is 2 meters a week, and that basically means that for every week, we want that area of your silage clamp to move back 2 meters, so that face of silage clamp to move back 2 meters. Fairly simple to understand, very important, because basically what we're trying to do is keep the face of your silage clamp as fresh as possible. If you were to leave that feed out rate longer than 2 weeks, then you're talking about basically it could become stale, it starts to break down, it starts to aerobically deteriorate. So the speed that you empty the clamp is really important, and that is dictated by basically the volume of silage you're storing and the amount of time you're emptying the clamp over. So we can work that out for you. I can't demonstrate that at the moment. It's quite a complicated thing to work out, but basically the run is 2 meters a week is the feed out rate you're looking for. The capacity required is the next one. So if you know what your feed out rate is, then you'll also know what your capacity is. And that's simply just saying, well, I want to store this many thousand tons of maize, this many thousand tons of grass, and this many thousand tons of whole crop, for example. Each of those has a different density. So obviously we'll have a different, requires a different weight and a different volume of actual silage clamp space. So we'll take that into account. Next point, so once we've sort of got our feed out rates and our capacity, we've got in our calculator, we've worked out what size the silage clamps will be. The next challenge is actually finding the space for it, which I'll talk about in the next slide. But basically, we might know what the clamp looks like in an ideal situation, but obviously it's got to fit on the footprint or in the area you've got on your farm or AD plant. So we'll cover that in a second. I've mentioned the number of cuts and the type of silage. Again, lots of cuts, which seem to be very popular at the moment, multi-cut. So you do 3 or 4 different cuts, a cut being, harvest, so 3 or 4 different harvests. You might want to build multiple silage clamps, so 1 clamp per cut. A really interesting one that we believe in a lot as well, because we supply the covers, is the clamp should be designed with the best to fit the silage covers that are most available. So if your clamp is 10 meters wide, we know that you can buy a 12-meter wide silage film. That makes covering it really simple, because you've got a bit of extra on each side, and you can cover it from the back of the clamp to the front of the clamp. Those things add up, and it's not essential, but it's small things like that that make you a lot more efficient, and you don't waste any plastic doing that. And then the last sort of thought process is, you can design all this wonderful silage clamp, but at the end of the day, you've got to be able to empty the clamp and fill the clamp. with the machinery you've got on site. If you're going to buy new machinery, then you've got that flexibility. But most farmers will say, I've got a loader or a telehandler that can lift a shear grab, say 4 meters high in the air. There's no point in then designing a silage clamp that's 6 meters high, because you'll never be able to empty it with your machinery, and you'll end up causing potentially accidents or having to go and buy a whole new machinery, which is a huge expense. So we take into account all of these different variables when we come up with the basic design of the silage clamp, which is how long it is, how wide it is, and how many of them there are. So I mentioned on the last slide location. In the UK particularly, you come up with the best design, and then you have to try and make it fit the farm that you've got, because often farms aren't enormous, they don't have a lot of space, and you have to try and make it fit the footprint of the farm that you're working on. So what we would try and sort of get people to understand is, you want your silage clamp to be above your dirty water system. So silage produces leachate and collects rainwater. So silage clamp collects rainwater, and silage itself produces leachate. You want that leachate and rainwater to be, well, to start with, that leachate and rainwater is quite dangerous. It has a high BOD, it can pollute waterways. So you have to have a sealed system and a way of managing the leachate that's coming off the clamps. What you want to do is basically ensure that all of your drainage happens through gravity. You don't want to be pumping anything if you can help it. So the best way to achieve that is to put your silage clamps at the top of your farm and your slurry store at the bottom of your farm, and everything is then flows through gravity. Another little point is, if you're going to build your new silage clamp, you don't want it facing the wind. So if you're in a very windy site in the UK, in Scotland and Wales, we've got some very windy farms where they're sort of exposed to coastal areas. If you can, and you've got the option, point the clamps 90 degrees across the wind, so the wind isn't blowing into the face. The wind blowing into the face causes two things. It forces oxygen into the silage face, and it also lifts the covers, which obviously isn't a good thing, because the covers are there, need to be airtight, so it doesn't work particularly well. Opposite to the sun, so if the sun's coming up and shining on the silage face all day long, it can heat the silage face, and any changes in temperature tend to cause more waste. So try and avoid having the sunshine on the front of your silage clamp all day long. All it'll do is increase the speed that the silage breaks down within it. UK regulations, 10 meters away from a watercourse. So basically, I'm not sure about other European countries, but I imagine they have similar challenges. You can only build your silage clamp within certain parameters. In the UK, they're set by the Environment Agency, and the Environment Agency basically say you cannot build a silage clamp within 10 meters of a watercourse. So definitely worth understanding that and following those rules. And the reason is that they don't want basically pollution to enter the watercourse. The final point is, when you build your silage clamp, you want to build it a long way away from where the watercourses are, but also to allow for future expansion. So you may build a clamp now, but in 5 years' time, you might think, I need to build another clamp, I'm going to double the size of my herd. To do that, you need to give yourself plenty of space. So always consider that as well. So I mentioned the fall of a site, basically clean silage at the top, dirty water at the bottom, and then a fall. And this is what we were talking about, the gravity. Basically keep the dirty water at one end and the clean water at the top end. Even sort of more simply is actually, obviously, you're also collecting the manure and the muck in the middle as well. So, in an ideal world, that is exactly how you design the perfect farm. Like I say, silage at the top and muck at the bottom. That might not be an option for most people, but if you have got the option, that's definitely worth doing. So we sort of march on next a bit. So we've kind of designed what we think the clamp will look like. We've got a length and a width. We've decided what the feed out rate is going to be. We've decided how high we're going to fill it. We've decided how many bays we're going to have. So you've got in your head, perhaps, I don't know, 3 bays, 12 meters wide, 50 meters long. This is the right feed out. This is the right site. It's at the top of a hill. The next thing to do is to identify the type of wall. So one of the key factors, interesting at the moment with silage clamp walls, is the loadings. Hasn't been taken very seriously in the UK for a long time because the weight of the machinery is fairly low. Silage clamps were fairly sort of amateur, so people were building clamps based on traditional designs. But what's happened recently is that the weight of machinery has gone up, the density of silage, because that's what you're trying to achieve to basically improve your silage qualities, improve the density. The silage density has gone up. And the walls haven't kept up with that. So the walls in the UK, some of them unfortunately are failing, and even some very new ones are starting to collapse. A collapsing, failing silage clamp is a huge issue for you. It could be incredibly expensive to sort out. It's also environmentally a bit of a disaster, because if your wall starts leaking and collapsing, then you know, you have the potential for a silage clamp leak. So this is where we come back to sort of thinking really hard about this and talking to a specialist and saying, well, actually, what size machinery am I going to use on this clamp? How high am I going to fill it? And what do I need to specify my walls to be able to achieve those things? A 30-ton tractor, not massively common, but if you start to add sort of a 20-ton loading shovel, you put water in the wheels, you put weight on the front, weight on the back, you put silage in the blade at the front as well, and then you drive that up right next to the edge of a wall, it's quite possible that you know, you could achieve them, and your walls are going to be certainly limit their lifespan, but also could be incredibly dangerous. The wall could fail, and you know, you could actually have an accident where someone could get hurt or badly injured because the wall has failed and machinery's fallen off it. So the first thing to really think about when you choose a wall is what do I want this wall to achieve, and I need to talk to a specialist. So here's a really good example of what I've already mentioned about walls and loadings. These are traditional, what I call traditional silage clamps, or old-fashioned silage clamps in the UK. These are silage clamps might be, I don't know, at least 40 or 50 years old. The ones on the left obviously were built inside a shed, but that shed was never designed to store as much silage as they put in it. You can see that right up to the top of the roof, the silage quality is going to be very poor. One of the pictures, you can see the vertical pillars that hold the roof up, they're being dented and banged. Structurally, they're going to be incredibly weak, but they were never designed for a big tractor. They were always designed for much smaller tractors. And then they're trying to use a big tractor in that environment. So the silage quality is going to be rubbish. There's a danger to the operator filling it. And we've got to try and move away from that. The other two photos are actually of not even maybe 5 or 6 year old silage clamps in the UK. They have different problems, but again, they still have challenges. The walls on the one here are actually started to move. So the walls weren't specified for a particular weight or height of filling, and they've started to fail. And what happens is they fail at the bottom, and then leachate goes under the panel. It starts to break down the foundations, and it causes more problems. On the one on the far right hand side, you'll actually see the leachate is actually attacking the steel at the bottom of the panel, and that steel will become weaker and weaker, and its lifespan will be much shorter. And as mentioned, you know, it could be a health and safety or environmental risk. So this is what we're talking about: loadings and design. So once you've decided what your loadings are going to be, you want to decide what sort of wall you want to consider. We've already talked through sloping and vertical walls. Each site has a completely different requirement, so it's totally up to the operator to decide with the best advice which one works for them. Obviously, we've already talked about coming up with the design. Now that design has to fit the parameters of the customer or the operator. In this case, budgets. So what can I afford to build? It might, you know, ARC might have said this is the best solution for you, but I can't afford it. So what is the next best variation of that that I can afford? Space. How much space have I got? I don't have enough room for a sloping wall, so I want to a vertical wall. Time is quite an interesting one because different systems can be completed in different time scales. The sloping wall is an interesting one because it's a good option to build for some people, but it takes longer because there's more groundworks or construction element required, whereas a vertical wall can be built and sort of ready to go in half the time or a third of the time. So definitely worth considering. Ground conditions, again, very similar. It's this thing about a sloping wall might be a better option on somewhere with a lot of clay, but if you're working on in a site with a lot of sand, you're going to have to basically look at alternatives, because you're going to have to spend a lot of money importing the clay to build the sloping wall. And then finally, regulations. Each system has to follow the correct regulations, and to achieve that, you need to go back through the process again, but also talk to your local environment agency or agency or sort of governing body to understand what do they expect you to do with your silage clamps. So definitely worth considering all those points, and one of those systems will meet all of those points. A question we get asked about loads, so I thought I'd cover it off now, so save lots of people asking in the future. Is the base material for silage clamps. So silage clamp walls are always concrete, apart from, I think there's some different examples of using actually wood, unbelievably, in Sweden. Concrete is a fantastic product to build silage clamp walls, but we recommend people cover them with plastics. So the silage isn't actually in direct contact with the wall. There's a plastic sheet that protects the silage clamp wall. The difference with the base, though, is that the base is in contact with silage all the time. And obviously it's being run on with heavy machinery all the time. So it has to be tougher than the walls. And that's why we think more and more that actually asphalt is the right answer. So very briefly, asphalt takes 2 to 3 days to install and have ready on most clamps. So it might take a day to lay it, and then 2 or 3 days for it to basically cure and become usable, which compared to, say, a concrete base, which might take up to 6 weeks to cure and become usable, is a lot quicker. Asphalt has a lot fewer joints, so concrete bases will have expansion joints in them to allow them to expand and contract. Unfortunately, concrete bases with expansion joints tend to collect leachate in those joints, and that's where they become weak and potentially fail. So we recommend asphalt because it doesn't have the same sort of joint. It's a much smoother, flatter joint. Very long term with asphalt as well, you can always skim and relay an asphalt base and use it within 2 to 3 days. Whereas a concrete base, once it begins to fail, you have very limited in terms of your options for replacing a concrete silage clamp base, and you may end up having to put asphalt on top of it, in which case you would probably have been better off to start with asphalt at the beginning and work backwards. So asphalt seems to be the one that we'd recommend, especially on the bigger clamps. Maybe on smaller clamps, concrete's still very much the way forward, but on bigger clamps, it's the right thing to do. Really quick point as well, you can also get the drainage a lot simpler, I think, with asphalt. You can sculpt it to make it do different falls and basically slopes and barriers and different bits and pieces can be built in with asphalt. You might be able to do with concrete. Final point on asphalt then, because again we get asked about this a huge amount, you should only use asphalt that's basically designed for the storage of silage, so silage clamp specific asphalts. In the UK, we have maybe a dozen products now, which are supplied by national companies, which are designed specifically for silage clamps. Very simple principle is silage clamp leachate is acidic. So whatever the product is you use has to be acid resistant. To achieve acid resistance, they look at the pH of the product and they alter it using different aggregates to basically create a neutral pH so that it isn't going to react with the acid in the leachate. A good example would be to remove limestone. So they remove limestone from the mix of asphalt. I think one of the other points I'd really like to drive home as well is something that we don't really consider enough about. So we sort of discussed silage clamp design from a quality and efficiency point of view, but I think what's really important is we understand silage clamp design from a safety point of view. So why are we worried about silage clamps and safety? Well, I think realistically in the UK, it's probably one of the most dangerous things you'll do on a farm is actually work on a silage clamp. You might work on them alone. So one farmer might go out in the morning and uncover his silage clamp. To uncover it, you probably have to work at height. So you might have to climb up on top of the silage clamp on your own. You probably have to do it in all weather. So you could be climbing on top of a silage clamp on your own in the rain. And in the UK, it's very dark in the morning. So you might be doing it in the rain and the dark. And then what you're walking on, so you're walking on to uncover the silage is basically a big pile of reasonably unstable material. So if you combine all those things together and you think, well, what other things do I do that are quite that sort of high risk on the farm? There aren't many really. And that's why I think you have to design the safety into the storage at the beginning. So, we talked about, covers and fill heights and bits and pieces. That's all part of it. And that's part of the service we'd be delighted to provide to all of our customers, is to advise them on that. I think in the short term, though, that the things that you can do now to try and make that safer, other than changing your silage clamp design completely, is to consider operators working in pairs, especially from an AD plant. Fall arrest systems, I think, are something that we need to work on as a future option. Is how do we stop people falling off silage clamps? Handrails seem to be a fairly obvious addition, but there must be something else we can do. I know these things actually become really important to people because we get asked about them all the time. So, fall arrest system, handrails. We mentioned building it in a sheltered area. So can we put a roof on the clamp? Can we build it somewhere where the wind is very low? I know snow, ice, frost, all these things have a big impact. So maybe that's part of the sort of conversation. And then from a practical point of view, and I'd advise this to anyone who works with silage or silage clamps, is don't go too close to an open silage clamp. Open silage clamps, basically the silage clamp face, so the area of the silage clamp at the front. An American guy who's put a lot of effort into basically silage clamp safety, and he talks an awful lot about this, saying basically you should stay at least the distance of the height of the clamp away from the clamp in the front. So if the clamp's 6 meters high, you need to say stick 6 meters away from the front of the clamp. Stay in your vehicle, I think it's a really good point. So don't walk up to the silage clamp to take a sample. Literally drive your vehicle up to the silage clamp face, and if you can, use the bucket, for example, on a loader to take that sample, then drive it away and take the sample from the loader. And finally, something I think we'd like to understand more, work with more, is basically how can we design silage clamp covers and silage clamps and tools to basically take the covers off, so the clamps, the netting, and the gravel bags and bits and pieces. So you can make the silage clamp safer through design, and you can make the silage clamp safer through best practice, and we've got to try and improve both of those things, because silage quality doesn't matter if you're basically, if you're being dangerous and someone gets hurt, then the silage quality doesn't matter too much, because you've got bigger problems at that point. So we kind of run through a load of different points. I'm just going to summarize a couple more that I think we ought to just sort of really put a little bit more emphasis behind, because these are the ones that we see people get wrong, and I would like, we would genuinely want everyone to do slightly better. So the first point is, this is one that unfortunately comes up again and again, and actually costs a significant amount of money to sort out. You need to understand the local laws for your country or region about the drainage of a silage clamp. So you cannot just have a go and hope it all goes okay. If you do get caught, you will be in trouble, and you will have to sort out the drainage design. Most in the UK, very simple set of regulations you have to follow, and you stick to them, and you understand that at the beginning. Why is that important? Well, silage clamp leachate is very hazardous. If you poured silage clamp leachate into a river, it will kill most of the wildlife, and we don't want that to happen, but we certainly don't want the what the consequences of the cost of clearing up that problem, and also the cost of future insurance bills and bits and pieces like that. So so those are the sort of environmental points. And then just to come back to where we started, it's really about, especially at the moment with the price of raw materials, it's really about optimizing the quality of the silage. So, you know, people suddenly starting to realize your silage is so incredibly valuable, and we haven't valued it as well as we probably ought to have done. So coming back to the beginning, investing in your storage is vital, reducing your waste is vital, because the most valuable feedstock you've got on your farm is silage. Bit more boring, I'm afraid, but basically silage storage, you have to look after it, and you have to look after it every year. You have to be ready to paint walls, repair joints. You have to be ready to reinvest. You have to be ready to knock stuff down and build new stuff. And that comes down to the next bullet point, which is whatever you've got now, or whatever you intend to build, you do have to live with for quite a while. So it's definitely worth spending a lot of time coming up with the right plan. It's not the end of the world if your clamps aren't quite right, but it is a real annoyance, I think, if you spend quite a lot of money on silage storage and then suddenly realise you haven't got the capacity expected. It isn't going to be safe for you to work from, and you're still creating a huge amount of waste. So it's really, really important you get that right. And again, this is the thing about, you can't change what you've already got because it'll be full of silage. So, and the long-term investment point, they all combine together to basically mean put the effort in to get your silage storage right, because it will make such a big difference to you. So final pointers: silage clamp design starts with silage quality and works backwards. Is the way that we should be thinking about it, not the other way, not what can I fit in this space or blah, 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 blah. It starts with quality and works backwards. You cannot make excellent silage in bad silage clamps. So you can make okay silage in bad silage clamps, but you cannot make excellent silage in bad silage clamps. You can make a silage clamp a lot safer by better design and better thought processes. And whatever you do now, you should be thinking about for the next 5 to 10 years, maybe even longer. So you need to be planning ahead with where you put your silage clamps and what design you go for. And ultimately, unfortunately, whatever you do end up doing is going to be very hard to change in the future. So give yourself the time to decide long term about what you want to end up with. A lot of that, I guess, all boils down to don't be afraid to ask for advice, ask a specialist, go and see some other people's silage storage, and ask a few questions. Don't rely on perhaps the simple solution. Unfortunately, it's not always the best. So that sort of brings me to the end of my bit. I can talk about silage clamps for hours. I'm sure you don't want to hear that. I'm sure Trevor will be quite glad that I got to the end.
No, you did a great job, and thank you so much, Will, for the detailed presentation. I think you really underscored the importance of designing a proper silage clamp or bunker, especially considering all the planning and money that goes into planting, growing, harvesting a crop later to be stored. It's necessary to consult with experts, as well as to use quality silage films to conserve and store that silage. And another really important point is the safety in silage clamps. It's an unfortunate reality that people do get hurt or even die in silage accidents. So proper design helps avoid or minimize that. So please consider that as well when considering your silage storage. We'll get started now with some of the questions. It's not too late to ask any questions, so if you have anything, please go ahead and head to the Q&A, which is at the bottom of your screen, where you can type an answer in that will answer. We'll get started now with the first question, which is, how would you describe the current storage of silage in the UK in general?
Yeah, thanks, Trevor. I didn't mention covers too much because I think we're going to cover that in the next couple of webinars, but they're as important as silage storage. So I recognise that a lot of the attendees today are from different parts of the world, so I can be sort of fairly general about the UK. In the UK, a lot of our silage storage was built maybe 40 to 50 years ago. And it was built for smaller tractors, smaller farms. And what happened is the farms got bigger, the tractors got bigger, the silage volumes got bigger, but the silage camps weren't sort of invested in the same way. I think there may have been some subsidies as well. So, you know, some sort of government incentives to build the initial silage camps, but they were never followed up in the long term. So the reality is we did some research with Cambridge University. The age of a silage camp in the UK is very old. They haven't been invested in. And as you saw from those photos, the challenge then becomes making good silage in them. It becomes really tricky. So yes, I would say it's poor. To be honest, I would say the quality of silage storage in the UK is poor, especially when we look at our sort of, I suppose, our partners in places like Holland or Spain or France, where they seem to have got a much better understanding of silage storage and silage quality and the importance of it. So poor, but we're working on it.
Well, there's certainly room for improvement always. So I encourage any listeners here in the UK to reach out to Will, who can help you with that. Going to our next question is, what is the simplest thing a farmer can do now to improve their silage storage?
Yeah, so going back to the age of silage camps in the UK, there's two problems with a very old silage camp. The first one is it's probably leaking and environmentally potentially a big risk. So the first thing is, I think you have to understand, is it, you know, am I polluting? The answer is possibly. And what do I need to do to stop that pollution? And the answer to stopping the pollution is basically investing in the drainage of what you've got. The second sort of most important thing to do is, if your silage camp's not in too bad a condition, then you can spend some money on basically flooring and painting walls and repairing joints. But ultimately, if your silage camp is very old and very tired and failing, then you have to replace it. So you kind of have three things to consider: is, you know, what's the environmental impact, what's the short-term maintenance I can do to maintain, you know, to basically add a bit of life to the clamp, and what do I need to do long-term to replace the clamp. So, I mean, a very, very simple thing is short-term, it might just be that you have to invest in more silage films for sidewalls, thicker silage films or longer silage films that cover more of the sidewall and more of the joint at the bottom. But the answer is long-term, it's not simple, unfortunately.
Okay. This next question, I believe you probably get very often. It's a bit difficult to answer. But what does a silage clamp cost to build?
Yeah, we get asked this all the time, because obviously that's what's important, is you want to make an investment that's good value for money. It's very site specific, so we don't have a single figure for it. What I would say is you might work on a cubic meter figure. So you might say the silage clamp per cubic meter, which is just obviously like a volume. You might say in the UK you could build a silage clamp for between 40 and 50 pounds a cubic meter, which obviously you'd have to, completely site dependent, and no one can hold me to that, because everyone will be different. Some will be cheaper, some will be more expensive. But that figure gives you a rough idea of where you might have to pitch your sort of costs. You'd obviously divide that figure over the lifespan of a silage clamp, which should be 20 years, you know, give or take. If you look after it, it'll last longer. If you don't look after it, it won't last that long. So it all depends on your site. There is a rough idea of what you could do, but you have to think of it as a long-term investment. So we would be delighted to do a more in-depth answer for those questions.
Okay. And our last question here for the moment is there any difference managing silage in the UK versus, for example, how it's done in the US, and why?
I think the biggest difference that I've noticed is in the UK, we don't have as much space. So our farms are often historically quite small. So we know we still have farms that have 100 cows on, and there aren't as many of them around. But the infrastructure has been built around that design of farm. So where in America you might have a larger farm that has room to expand, in the UK we might have a much smaller farm that was designed around a much smaller number of animals. They don't have the room to expand, physically get bigger, they don't have the room. So what they have to do is try and build clamps that will contain a larger volume of silage in a smaller area. So we see a lot more walled clamps. We don't see many big flat pads in the UK. We have different regulations as well. In America, I understand we have, there is a lot more of these enormous big sort of areas of asphalt or concrete covered. It just wouldn't work in the UK. We just couldn't. We don't have those free areas to do that.
Right.
In the US as well, I think the availability of labour to cover large areas might make them a bit more of an option. So there are different ways of doing it. I think the USA is also a massive country, so it might be that in some parts of the US you can do one thing, in other parts you can do other things. It's not quite the same in the UK. The climate's fairly similar, and the farms are reasonably similar. But the answer is there's a lot of differences and a lot of similarities, but ultimately we're all trying to achieve the same thing, which is store as much of the crop's potential in a clamp, so that we can make the most of it over the winter when we can't grow the feed.
Right. Okay. Well, that concludes the Q&A section here and this webinar for now. So thanks everyone again for tuning in. I encourage you to go to visit the websites both of Agri-Plastics Community and ARC Agriculture. There you can find contacts to reach out with any further questions or consultations about your silage storage. This is part 1 of a 3-part series, so please sign up for the next webinar, which will be in June. That information, again, is also on the Agri-Plastics Community website. Will, would you like to sign out or anything else? I appreciate your time.
No. I just wanted to say thank you very much to yourself, Trevor, the Agri-Plastics community, and to Gabriella for organising everything. If we can help anymore, please let us know. Like I say, there's some fairly simple things you can do to improve silage storage, and I look forward to catching up with everyone. I think I'm doing the next one as well, so I'll talk more about plastics then.
Excellent. We look forward to it.
Thank
you, everyone.